This lesson is about inverse trig functions. Let's jump down to the interactive panel, go across to inverse trig functions, and we'll press play. In the last lessons, we worked on the exact value table. Now we're going to use it to solve some questions from the previous lessons more accurately, then use it to do something completely new. Use the green Show Hide button to show or hide the exact value table during this lesson. So click on this and it'll get it out of the way if it is in the way, and you can show it again if you need to see it. Trace another unit circle by dragging the log around. Okay, find this angle. Let's say maybe like 30. Nice. Now, for the horizontal length, we use cos theta, but instead of using a calculator, let's use the table this time. What's the value of cos 30 according to the table? Okay, so cos and then 30 would be root 3 on 2. The square root of 3 over 2. Nice, and for the vertical length, we use sine, so use the table to figure out the vertical length. Okay, well the angle's still 30, so sine and then 30 would be 1 over 2. Awesome. Now try this angle. Okay, looks like it could be maybe 60. Use the table to find the horizontal length and type it in. Okay, horizontal length is cos. Cos 60 is 1 over 2. Oh, something happened there. 1 over 2, there we go. Now the vertical length, well, sine 60 is root 3 on 2. Now try this angle. Okay, 45. Use the table to find the horizontal length and type it in. Okay, table, so cos 45 is root 2 on 2. And now the vertical length, sine 45, also root 2 on 2. Now try this angle. Alright, looks like 90. And then probably going to have to do the horizontal, so cos of 90 is 0. 0. And then vertical is sine of 90, which is 1. Awesome. Now try this angle, and it's 0, because sometimes it's hard to see. So it's already kind of there, but yeah, it's just 0. We don't rotate up or down at all. And then sine and cos, so cos of 0 is 1. And then for the vertical, sine of 0 is 0. Now let's learn how to apply the table to angles that aren't on the table. These are angles in the other 3 quadrants. First, find this angle. Okay, so the point is, if we're going to be able to use the table to solve it, then it has to be related to one of these angles here. So remember the symmetry lesson we were doing, where I can have a 30-degree triangle over here. Let me type it in. 30. And then the side lengths in this triangle are going to be the same side lengths as if I have a triangle. I'll draw it like this. If I have a triangle over here. And so if I have a 30-degree angle down here, then what angle would I have to do to get the log to go over there? So it'd be 180 and then back 30. So that would be 150. I need to type it in over here. As we learned in a previous lesson, this 150 degrees actually creates a 30-degree triangle with the x-axis. Yeah. That means we can use the table values for 30 degrees still, as long as we make them negative when needed. For For example, this triangle goes to the left, so cos theta will be negative, but it still goes up, so sine theta will stay positive. So with that in mind, use the table to find the horizontal length and type it in. Okay, so 30-degree triangle, so it's going to be this like similar to cos 30. So cos 30 is root 3 on 2. So let's just type that in. Square root of 3 on 2. But that will be going this way. But because we're over here now, we just need to make it negative. Make sure you put the negative out the very front. If you put it in the numerator here or on the bottom for some reason, it won't work. Oh, okay, looks like it'll draw it, but it won't accept that as the answer. So if you just type it in as negative and then square root of 3 on 2, it'll automatically put the negative out the front. If you already typed it and then you're going to add the negative in after, just don't add it to the numerator. Make sure you add it out the very front and then it'll work. And as always, if you get stuck, you can press skip if there's some sort of formatting issue. Cool. Now the vertical length. All right, the vertical length should be the same as sine 30, but is it going to be positive or negative? Well, it goes up, so it's still going to be positive. So sine 30 is a half, so we should just be able to type in a half. Perfect. And then we can see it happening there. Awesome. Now you try with this one. Okay, so we could just think about what angle would get us there, but also if we're going to be able to use the table, then it should be related to one of these, which means we should have some sort of triangle like this and some sort of angle here that's on the table. And this angle down here looks like it could be maybe 60. 45 would only be like halfway like there. So I reckon probably it's going to be related to 60. So if this here is 60, then I could go to 180 and then go back up 60. So 180 minus 60 is 120. Nice. Now we need to notice this 120 degrees actually creates a 60-degree triangle with the x-axis. Yeah, like I was just saying. That means we can use the table values for 60 degrees still, as long as we make them negative when needed. So with that in mind, use the table to find the horizontal length and type it in. Okay, so it's a 60-degree triangle, even though it says 120 degrees there. So 60-degree triangle, cos of 60 is a half. But if I just type in a half, that would go that way. So we need to make it negative, because now we're over here. And the vertical length, we can use sine of 60, and get the square root of 3 on 2. Nice, now try this next one. Ooh, okay, now we're down here. So using the x-axis, think about what triangle this would create. Looks like it's maybe 45 degrees. And so if we want to get down to here, we could get to 180, then an extra 45, again, knowing that it's probably going to be something on the table. So yeah, we should be able to do 180 plus 45, which is 225. Nice. Now pay attention to what triangle is created by this 225 degree angle. Yeah. Yeah, think about what the value of theta would be and therefore which values you should use in the table. Then use the table to find the horizontal angle and type it in. So we said it's a 45 degree angle down here. And so we can use the 45 degree values. We just need to make them positive and negative. So cos of 45 is root 2 on 2, but that's going to go that way. So we need to make it negative. Now the vertical length, and this one should be negative as well. So sine of 45 is root 2 on 2, but we're going down. So negative root 2 on 2. And let's do 2 more in this final quadrant. Find this angle, still using a positive angle. Okay, all the way around here. But we could think about what angle could be in this section. It looks like maybe that could be 30 degrees from the table. So if we go all the way around to 360 and then come back 30, we should get 330. Nice. Now think about what triangle is created by the 330 degrees, and then what values should we use? So we just said that was going to be 30. So we should use the 30 degree values. Horizontal length would be cos 30 square root of 3 on 2. Is it positive or negative? Well, it goes this way, so that's positive. So square root of 3 over 2. And the vertical length, should be able to use sine 30, so a half, but just a half would be going up. So let's make it a negative half. Awesome. Let's try a negative angle for the last one. Find this angle using a negative angle. All right. So going down here, and we don't need to do anything special. It's just straight from there to there. Looks like it could be 60. Oh, whoops. That would be positive 60. So that would be up here. So I should have done negative 60. Oh, here we go. Negative 60. There we go. Nice. Now think about what triangle is created by this negative 60 degrees. Well, it's just in there is 60. And so which value should we use in the table? Should just be the 60 degree values. Horizontal length would be cos of 60, which is a half, but are we going positive? Yes, we are. So straight away we can just do 1 over 2. Now vertical length, so 60 degree triangle, we can use sine 60 is square root of 3 on 2, but it's not just any 60 degree triangle, it's one that goes down here. So we can go negative square root of 3 on 2. Awesome. Now here's another thing the exact value table lets us do. Imagine it's nighttime and the frog can't see to the edge of the pond. Ooh. But the frog can sense that if he hopped to the left at a distance of root 3 on 2, so if he just goes this way, okay, there would be an insect either directly above him or below him. All right. And because we know the insect is on the edge of the pond, it can only be either here, so there, or here. Okay. And if we can work out the angles to rotate the log to, we can try and get Mr. Frog his insect. Okay, so we just work on what angles would actually get him over here and over here, which would have a horizontal distance of negative root 3 on 2. Then we can get him to the insect. So this is one where we don't know the angle. Most of the time we've been working with, we know the angle or we work out the angle straight away based on what we know. But here we can't see a lot. All we know is that we're going to the left by negative root 3 on 2. And so we have to use that information to figure out the angle. So, because the horizontal length is negative root 3 on 2, we know that cos theta equals negative root 3 on 2, okay? Now, using the table, which angle makes cos theta equal root 3 on 2? So don't worry about negatives or anything like that, but just what angle should we be looking at in the table? Because it's a root 3 on 2, even though it's negative, it's going to be related to this angle. So cos root 3 on 2 would give us, that would be a 30 degrees, so there. That's right, so we know it has to involve a 30 degree triangle. I'll hide the table here. Yeah, this is going to be 30 degrees in here. Use that information to work out the angle to rotate the log to so we can check this first location. Okay, so if it's 30 degrees in there, think about 180 minus 30, so 150. Awesome. Looks like the insect wasn't here. That means it must be in the other possible spot. Again, because the horizontal length is still negative root 3 on 2, it's going to involve a 30 degree triangle. Use this to work out the angle and type it in. Okay, so this time 30 degrees will be down here. So 180, then an extra 30 will be 210. Nice. Nice, the insect was here. Great job. Now, you try this next one. The frog is sensing that if he hopped to the left at a distance of 1/2. Okay. There would be an insect either directly above him or below him. Okay. Because we know the insect is on the edge of the pond, it can only be either here, so there, or here, down there. Because the horizontal length is -1/2, we know that something theta equals -1/2. Which function goes in the blank? So, well, horizontal length is cos, so we can click cos. Nice. Now use the table to find the reference angle and apply that to find the angle at the first position. So reference angle just means what angle gives us side lengths of 1/2 for cos from the table. And then from there, we can figure out what actual angles, like what angle do we need to rotate to create this angle in here. So, -1/2, well, let's just not worry about negatives just yet. So just 1/2 itself, we need to involve 60 degrees. So that's our reference angle. That's what we call the reference angle. So, okay. Need to involve 60 degrees. So that means there's a 60-degree angle in here. So 180 minus 60 would be 120. Awesome. Nice. Yep, just said that. Awesome. Let's check the other one just in case there's also an insect there. Work out the angle, then type it in. Okay, so 60 degrees still. We'd have to put 60 degrees here, so 180 plus 60, 240. Nice. 180 plus 60, 240, and the insect was here. Perfect. Awesome stuff. Let's do a few more to see the different variations that can happen. As you'll see though, the method is very similar for all of them. This time, the frog can sense an insect if he goes √2 upwards. And goes either left or right. Meaning it could be in one of these two positions. Okay. On an exam, often these questions are just given as sine theta equals √2. So you won't see any of this other stuff, obviously. You'll just be given this, or you'll have a question that involves that as part of it somehow. And the whole point of this whole course really is to give you tools to picture how this could go. And so you don't have to have this full drawing and setup and stuff, but if you get given a question like this, when I'm solving these questions, I will draw like my own little circle, and I'll draw these kind of, I'll draw like the vertical length here, and I'll think about how that puts it over here. And so I'll do a simplified drawing of this situation. So if you ever get stuck on a question like that, okay, pretty much saying that here, you can think back to what it would look like with the frog in the pond, or even scribble a quick sketch on a spare piece of working paper. This is really, this makes a big difference for a lot of people, is just doing a quick sketch of it. That is often the only thing that my students are missing when they're stuck on a question. I tell them just draw it out, and they're like, oh, now I see it. So it only takes a second just to draw it out. So use the table to figure out the first angle that makes sine theta equal √2, then type it in. Okay, so reference angle, or also just the actual angle here. So root 2 on 2, sine 45. 45. We'll just type in 45. Nice. And how do we know it's sine? Well, it's the vertical, so that uses sine. Nice. So we could write our answer to the exam question as theta equals 45 degrees. Okay. So if we do need to do a proper answer, now how do we type theta? If you forget, there's a little help button here. Theta, we just type in the word theta. And then degrees, if you forget, DEG for degrees. So theta equals 45 DEG. Nice. But then we also need to find the second possible angle. Do that now and type it in. Okay. So to get a sine for root 2 on 2, it needs to involve 45 degrees. That first one was easy. Now we just need to make sure the 45 degrees are down here. So we go 180, then go back 45. That would be 135, I think. Nice. Nice. So then we could add to our answer to the exam question and also write theta equals 135 degrees. Okay. Theta equals 135 deg. Nice. Great job. Let's do another. Imagine the question was sine theta equals negative 1/2, right? Because sine is for the opposite, and in the unit circle, that's the vertical side. This tells us that the angle or angles we need will result in an opposite length of negative 1/2. Okay. So again, if the frog went down 1/2, cool. And it could go either left or right. Alright. Meaning it could be in one of these two positions, there and there. Okay. So find the two possible angles for theta, starting with this first one. Okay. So opposite and vertical, so that's going to be involving sine. And then sine to get a length of 1/2. So sine 1/2, that would involve a 30-degree angle. So down here has to be 30 degrees. So we go 180, then an extra 30. All right. So that would be 210. Cool. Make sure I'm typing over here. 210. Nice. So we could write our answer to the question as theta equals 210 degrees. Let's type that in. Theta equals 210 deg. Nice. Now find this second possible angle. All right. It has to involve 30 degrees still, meaning down here is probably going to be 30 degrees. So if we went all the way around 360, then went back 30, 330. Nice. So then we could add to our answer to the exam question and also write theta equals 330 degrees. Okay. Theta equals 330 deg. Nice. Let's use negative angles for this last one. Okay. Because cos is for the adjacent and in the unit circle, the horizontal side, this tells us that the angle or angles we need will result in an adjacent length of negative root 2 on 2. Okay. So again, if the frog went to the left, root 2 on 2, and it could go either up or down, meaning it could be in one of these two positions. All right. So find the two possible angles for theta, starting with this first one. Remember to use negative angles for this one. Okay. So cos root 2 on 2. cos and root 2 on 2, that has to involve 45 degrees. So in here would have to be 45 degrees. So negative angles, to get this one, we have to go around 180 and then back 130, sorry, and then back 45, which would give us 135, and it's negative. So negative 135. Nice. So we could write our answer to the question as theta equals negative 135 degrees. Nice. Now find this second possible angle. Remember to use a negative angle still. Okay, so 45 in here, 180 plus 45, 225, and we're using negative angles. Nice. Then we could add to our answer to the question. So we're just going to write it as theta equals negative 225 degrees. Nice. There's a pattern between sine and cos and the negatives and positives that's helpful to notice. If cos theta equals a positive value, then the adjacent length goes this way. Yeah. Then because we're not told if sine theta is positive or negative, it could either be up or down. All right. So that means if we're told cos theta equals something positive, we know that the angles must be in which quadrants? Okay, well, yeah, it looks like it's not these ones. It has to be either up here or down here. Exactly. And so cos theta is positive in those ones. And if cos theta equals a negative value, then the adjacent length goes this way instead. And again, because we're not told if sine theta is positive or negative, it could either be up or down. So that means if we're told that cos theta equals something negative, we know that the angles must be in which quadrants? And it would be 2 or 3. Exactly. Awesome. Now, for sine, if sine theta equals a positive value, then the opposite length goes up. Then because we're not told if cos theta is positive or negative, it can either be left or right. Okay. So that means if we're told that sine theta equals something positive, we know that the angles must be in which quadrants? No, it's not down here. It has to be either there or there. Exactly. Okay, so sine theta is positive there. And if sine theta equals a negative value, then the opposite length goes down. Okay. And again, because we're not told if cos theta is positive or negative, it could either be left or right. So that means if we're told that sine theta equals something negative, we know that the angles must be in which quadrants? Well, yeah, it has to be down here, 3 and 4. Exactly. And finally, let's do tan. Remember how tan theta is like the gradient of the line? So if tan theta equals something positive, then the gradient of this line will be positive. So let's make a line in each quadrant, starting with quadrant 1. Okay, so from here, just up to here. And as this line runs to the right, it rises positively. Okay. Meaning the gradient and tan theta is positive. Exactly. Now, let's make a line in the second quadrant. Okay, just drag it up to there. And as this line runs to the right, so from left to right, it rises negatively, so it goes down. Cool. Meaning the gradient and tan theta should be negative. Exactly. Now for the third quadrant. Drag the button to create the line. Okay, go down here. And as this line runs to the right, it rises positively. Meaning the gradient and tan theta is positive. Exactly. And finally, what if the angle puts the line in the fourth quadrant? Just drag the button. As this line runs to the right, it rises negatively, meaning the gradient and tan theta is going to be negative. Exactly. Phew, that's kind of a lot of information. But we can summarize it with this handy trick. Looking at the first quadrant, which ones are positive? Well, that's positive, so they're all positive. Well, click all. That's right, let's put A for all here. And now looking at the second quadrant, which ones are positive? Okay, cos and tan are negative, so just sine is positive there. That's right, let's put S for sine here. And now the third quadrant, which ones are positive? It looks like it's just tan. Okay, let's put a T for tan. And then this one looks like it's just cos. So cos. Let's put C for cos down here. Okay. So then if we get a question like this, cos theta equals square root of 3 on 2. I don't know why the brackets are there, but anyways. We know that the possible angles for theta are in the first and fourth quadrants because cos theta equals something positive. Okay, so because this cos theta is positive something, that means the adjacent length goes from left to right, goes over here, which means the angle has to be like something there or something down here. So either in this quadrant or this quadrant, or both. For this question, which quadrants would our angles for theta need to be in? Well, cos theta is negative, meaning it would go this way. And also we can just look here. Cos is negative in both of these ones. So 2 and 3. How about this one? Which quadrants would our angles for theta need to be in? So sine, positive root 2 on 2. So all of them are positive here. And then sine is positive there. And then sine is negative in those ones, so it won't be those. Awesome. And this one, which quadrants would our angles for theta need to be in? Well, they're all positive here, so it can't be there because it's negative. And tan is also positive down here, so it can't be 1 or 3. And tan is negative there, and tan is negative here. Super. How about this one? Cos, and it's negative. So cos is negative here, cos is negative down here. Lastly, this one, tan, and it's positive, so everything's positive here. Tan is also positive down here. There we go. And the way to memorize these letters to solve these questions faster is to spell the word cast, starting with C on the bottom right, C, and then A there, and then S there, and then T, cast. Because we measure angles usually going this way first, this in my mind, this is like the first thing, and it's definitely quadrant 1 as we call it. So you might be tempted to start spelling the word cast from here, like C-A. Once you do it a few times, you'll remember to not make that mistake. But at the start, if you're going, oh, does it start here, or does it start here, or where do I start spelling from? Just remember that everything's positive here. So A for all of them are positive here. So the A has to go there, and then that can kind of help you from there. You'll get the hang of it after you try it a few times. Okay, that's it for this lesson. Let's let Mr. Frog sleep. Okay, we did all of that. Whoa. And we unlocked level 8. Nice. Go ahead and try the practice questions. Don't forget there's answers for each one so you can check, and there's also an explanation, a video explanation. Feel free to try it. Feel free to try the question, but if you're like stuck, you don't know really what to do, then watch a bit of the explanation. You can see how I'm doing some of the questions, and then you can go back and try them yourself. Try all those. Once you finish, go ahead and tick off this lesson and go on to the next one.